Okay, so let's apply P4. So what do we do wherever x is? Put ax. Yes or no, then do it. That's what our P4 says. So what do we do wherever x is from 0 to pi? Put ax. What is our a? It's pi. So pi x, 1 plus sin pi x. Let's take this as something. This is our I, okay? So the new I that came up is this. If I separate this, what do I get when I'm equal to I? I'm just separating 0 to pi. So pi, 1 plus sin 180x. What do I get? Sin x. It's the second quadrant. Sin will be positive, okay? Then what? It's minus. Let's write dx. Then it's minus. So minus written as 0 to pi. X, 1 plus sin 90x is sin x. Sin x dx. Okay? Now, if you look carefully, you'll see that if I add this one, I plus I, to it, then this will cancel out. Yes and no. So, let me add this. Consider this the first. Consider this the second, on adding first and second. So, we're adding first plus second. So, what do we get? 2i equals what do we have? 0 to pi x, 1 plus sin x dx. And what do I have? 0 to pi, 1 plus sin x. And what is this? Minus 0 to pi x, 1 plus sin x dx. Okay, same. This is positive, this is negative. Cut it off. So what do I have left? 2i equals integration of pi. So, take out the constant. So, what do I have below? 1 plus sin x. Tell me, how do we integrate this? This won't integrate, right? So, let's do something. To eliminate whatever's in the denominator, the only thing that comes to mind is to multiply the top and bottom by sin 1 sin x. Can I do that? If we do it both up and down, there won't be any problems. Now what's the result here? A plus b asterisk ab means a squared minus b squared, right? So what do I get? What do I get above pi 0 to pi? What do I get below 1 sin x? 1 whole square means 1 sin squared x dx. So what do I get from here? 2i equals this pi. Then, what is the integration above 0 to pi? What is 1 sin x and what is below? 1 sin squared x, which is equal to cos squared x. If anyone has any doubts, let me explain. This is the formula you've seen many times. Sin squared x plus cos squared x equals 1. What will be the value of 1 sin squared x from there? Cos squared x will be dx. Now separate it. Okay, we have reached the answer. The answer is in front of us. Now 0 to pi 1 cos squared x is then minus. So minus sin x cos squared x and then dx. If you want, you can separate it so that it is a little easier. It can be done easily even without separating. But let me separate it so that you understand. What will be 0 to pi 1 cos squared x? It will be sec squared x. Then dx is again minus, so it will have to be multiplied by minus pi as well. So what is pi 0 to pi sin cos? It is tan and 1 cos will be left because cos squared is below. So take that cos up and it will become sec. So, does anyone have any doubts about how I wrote tan x asterisk sec x? Look, what's sin cos tan below? It's cos squared x. A cos will be left over. That cos goes up and we get 1 cos. It's sec. So, we get sec x. Okay? There's a formula for this too. And there's a formula for this too. What is the integration of sec squared x? It's tan x. And what is our integration of tan x sec x? Tell me, it's sec x. Okay? The formulas for both are written in our textbook. So we won't have any problems here. Instead, I'm going to write tan x from where to where do I integrate? I have to do it from 0 to pi. Then it's minus pi, So what is our integration of tan asterisk sec x? It's sec x. Okay, this is the formula for sec x. Then we get 0 to pi dx. What do we get when we integrate this? We get sec x. What do we get when we integrate this? We get tan x. Now just plug in the values, you'll get your answer. So what do I have here? 2I equals, put the upper limit here. So what is the value of tan pi? It's 0, then tan is 0, so this is 0. Then, minus pi of minus pi, what is sec pi sec pi? We have this, we have the third quadrant, so we get minus 1, okay? And what is our sec 0? 0 is 1, right? Yes, it is 1, so minus 1, okay? So what do I get? 2I equals pi. And what's in the brackets? Minus 1 asterisk minus 1, so minus 2, so 2I equals 2 pi. 2 cancels out, so what do we get? I equals pi. That's our answer. Okay,